Peace be upon you, a sign of any celestial body. Without exception, once it exists beyond our atmospheric layer, it transforms into a shining object for Earth, regardless of its size or duration, whether satellites, planets, black holes, or even galaxies. Even artificial bodies like rockets and screws all shine in the sky. The only difference in brightness and light is that some bodies, like stars, have inherent luminosity, while others, like most bodies, depend on the light falling on them. Hence, the sky is filled with shining objects, some overlapping each other. Welcome, I'm Amr Abdelnabi, but before we begin, if you're new to the channel, don't forget to subscribe and hit the bell icon to receive our videos promptly. Scientists say that under ideal conditions, the naked eye can see between 2,500 to 5,000 stars in the sky from each side of the Earth. So, disregarding whether you're in the northern or southern hemisphere, you'll see a maximum of 5,000 to 10,000 stars in the sky. Of course, this variation has many reasons, such as light scattering or light pollution, especially in large cities. If you go to the desert at night and look at the sky, you'll notice a significant increase in the number of stars and brightness you can see. However, among all the shining bodies we see from Earth, besides the sun and the moon, one notable celestial body is Venus. Venus's brightness for us is approximately 4.89. Before you ask about this strange degree, let me ask you a simple question. Do you think Venus would have the same brightness for us on Earth if we were living on another distant planet away from Venus? Definitely not, and this could pose problems for us. Unless we have a relativistic issue according to the observer's position, knowing the brightest object in the universe is a very difficult matter. That's why we need to first understand what's known as apparent magnitude. The closest stars to Earth, of course, include the Sun, which is approximately 150,000 kilometers away from us. It takes light about 8 minutes to travel this distance. The Sun's apparent magnitude for Earth is 26.74. Scientists use the absolute magnitude scale to measure the brightness or luminosity of celestial bodies. In fact, every object in space has at least two magnitudes of brightness, one relative to us on Earth and the other absolute, which expresses its true brightness, regardless of whether it's close or far from us. The absolute magnitude of the Sun, for instance, is 4.8. This is considered very faint compared to the shining bodies in the universe. In this episode, we'll focus on the absolute magnitude scale, or the absolute brightness, regardless of whether we see it from Earth or not, particularly from the stars we see from Earth, which have strong absolute brightness, despite their small size. One such star is Sirius, or the Canis Majoris, which has an absolute brightness of 1.46. By the way, Sirius was one of the most important stars for the Arabs to the extent that it was mentioned in the Quran, Surah An-Najm, verse 49, affirming that even the star they worship was created by the Almighty. Surprisingly, Sirius is not the closest star to us. It's about 8.6 light-years away from our solar system, while Proxima Centauri, the closest star, is about 4.3 light-years away from us. However, since Sirius has an absolute brightness of 11, it's not visible to the naked eye from Earth at all. The human eye, under ideal sky conditions, cannot detect stars with an apparent magnitude dimmer than +6, according to available information. R1 Beta 27 is considered the brightest star observed so far, with an absolute magnitude of around 12.6. Although it's not the largest star in the universe, its young age and composition make it the brightest star known. Its location in the Large Magellanic Cloud, about 163,000 light-years away from us, makes it shine about 10,000 times brighter than our Sun. Its energy output every 5 seconds equals the energy our Sun emits in a year. However, do you think R1 Beta 27 is the brightest object in the universe, if we exclude supernovae and hypernovae? R1 Beta 27 is indeed considered the brightest star in the observed universe, but at the same time, it won't be crowned the brightest object in the universe because there's something even darker, which is the part of the universe that, according to available information, AR1 Beta 27 is considered the brightest star observed so far, with an absolute magnitude of around 12.6. Although it's not the largest star in the universe, Its young age and composition make it the brightest star known. Its location in the Large Magellanic Cloud, about 163,000 light-years away from us, makes it shine about 10,000 times brighter than our Sun. Its energy output every 5 seconds equals the energy our Sun emits in a year. However, do you think R1 Beta 27 is the brightest object in the universe if we exclude supernovae and hypernovae? R1 Beta 27 is indeed considered the brightest star in the observed universe. But at the same time, it won't be crowned the brightest object in the universe, because there's something even darker, which is the part of the universe that almost the same in brightness through the telescope. But the amazing thing is that the star is 300 light-years away from Earth, while the quasar next to it is 9,000 light-years away from us. Yet, the quasar's absolute brightness is 31. So how do you comprehend this brightness? Consider that the sun's brightness for us on Earth is less than -27 degrees, meaning the absolute brightness is greater than the sun's brightness for us. So, we've reached the end of this discussion. You've been great listeners. Before you leave, let us know who made it to the end. And don't forget, if you have any suggestions for an episode, write them in the comments. Most of what we do now is inspired by your comments.